Okay, hello everyone. Welcome to all in Pune University. My name is Dr. Manish Singh and I'm an associate professor in mechanical engineering department. And this is video lecture series on basic mechanical engineering, and this is lecture number 2 of unit 1. So in this lecture, I'm going to discuss with you about pattern. Okay, so let's see. This is the outcome. In this lecture, I'm going to deliver a lecture level outcome pattern and their types, pattern material, selection criteria of pattern material, and then some MCQs. So at the end of this lecture, the students are able to understand or learn how to define pattern and what is the role of pattern in the casting process, and then they also identify and compare different types of pattern, their application, and the components that can be made by from the different patterns. And next, they also understand what type of material used for pattern making and what are the essential properties. Next, uh, they also able to explain the criteria for selecting of pattern material, because different pattern materials are used. So what are the particular criteria through which you can select the appropriate material for pattern making? And at the last, pattern material application. This is the very essential thing which also learned at the end of this lecture. So first, let's see with definition of pattern. So pattern is nothing but it is a replica of an object which is to be cast. Is it right? Pattern is a replica of an object which is to be cast. जो भी हम pattern are the foundryman tools, obviously, and which is defined as the replica, means it is a mirror image of a pattern of a final object, obviously with some modifications, correct? So the pattern size is not exactly equal to the size of the object. Obviously its size is slightly either bigger than the actual object or slightly smaller than the actual object. Mostly we make bigger than the actual size of the component, and these modifications are in terms of allowances, chaplets, and padding. So in brief, if I tell you how to define pattern, then simply say pattern is a foundryman tool and it is defined as a replica of an object which is to be cast with some modifications, and these modifications are in terms of allowances, chaplets, and padding. And the mold cavity is always made with the help of these patterns only, and the pattern and their part to be made are not same. Is it right? Both are different. I already told you sometimes the patterns are made by slightly bigger than the actual size, and sometimes it is smaller than the actual size. It depends upon the nature of material and nature of the casting. Next, a pattern is always made larger than the final part, and the excess dimension of the pattern is also named as the allowances. So this is the basic introduction or definition of the pattern. Next, we have several types of pattern, like we have a single piece pattern or solid piece pattern. And obviously when we want to make a very small object with a very simple shape and size, then we use this types of pattern. Next, split pattern. Yes, slightly if complexity increases, then we, instead of single piece pattern, we use split piece pattern. And in this, the whole object pattern is divided into two or more pieces. Next, pope and drag pattern, and in this, half of the casting is made in the pope and half of the casting is made in the drag. And the mash plate pattern, this is advanced version of pope and drag pattern. In this, we have a single plate in which we attach pattern, both part of the pattern. Next, gated pattern. If the gating elements are included with the pattern, then this is called gated pattern. Loose piece pattern. Loose piece pattern means those patterns when we need to make projections which are not possible by a single unit, then in this case we use loose piece pattern. And next, a sweep pattern. Obviously when we need to make a symmetrical large object, then this kind of pattern is used. And similarly, segmented pattern, this is also used for making a symmetrical object with a large in diameter, like a flywheel or pulley. Skeleton patterns, obviously when we need to make a very large casting, like a turbine rotor, hydraulic turbine rotor, whose size is approximately the size of this room. So this large casting can be made with the help of skeleton pattern. Next, follow-on pattern. When we make a very thin pattern with thin casting, then during the ramming, the distortion tendency takes place. To avoid this, we always use a follow-on pattern. So let's see the detailed description of all these patterns. So basically, these are the 10 patterns, basic patterns that can be used for making a casting. So let's say this is a single piece pattern. You can see here this is a pattern and this is a single piece pattern, correct? And why it is called single piece pattern? Because the whole object have only one pattern. This is a only single piece of pattern, okay? And it is an inexpensive pattern and simplest type of pattern, and it is suitable for making a small size with a very small scale proportion production, okay? Simple shape with a small size and very small scale production that can be used. Is it right? So this is since this pattern is made up of a single unit, that's why it's called as a single piece pattern or solid pattern. Next step we have a split pattern. Then obviously the solid pattern, if you have a slight complexity in object and which is not possible to make with the help of single unit of the pattern, then in that case we use split pattern. In this pattern, basically the whole pattern is divided into two parts. You can see this is one half and this is another half, correct? And one half is made in the core portion and another half is made in the drag portion, and after that we just assemble like this. You can say this is a core portion which is made with the help of one piece of the pattern, and similarly this is another half which is made with the another half of the pattern, that is called as drag. And when we assemble both the mold cavities, and obviously here we make a pouring basin, sprue and passages for a metal flow. Is it right? Like this. Like this. So for it, we make separate both parts separately. Is it right? This half portion which is called as scope, and this is another half portion which is called as drag. Half portion is made with the half portion of the pattern like this. Suppose with the help of this we can make this part, and with the help of this we make this part, and after making both the parts we just assembled. And after assembling we just make a this getting element so that we can pour the molten metal, and obviously after assembling pouring of the molten metal we enjoy the casting process. Is it right? So this is basically this is a split piece pattern. So obviously remember, split piece pattern is mainly used for making slight complex object and slight, or we can say medium size component. Is it right? And this is most widely used pattern, correct? Next is scope and drag pattern. So now you can see in this type of pattern we have a two plates. This is plate 1 and this is plate 2. Half of the getting element along with the pattern attached with the one plate, and half of the getting element and with the remaining part of the pattern is attached with the another plate, correct? So this types of arrangement is called as scope and drag pattern, and obviously this pattern is made in the core portion, and this pattern mold cavity. With the help of this pattern we make in the core portion, and the mold cavity half part of the mold cavity is made with the this portion which is called as drag portion. Is it right? Then obviously with the help of this the entire mold cavity along with the getting element all are produced with the help of these patterns. Is it right? So this is called as scope and drag pattern, and it is an extension of the split pattern. In this scope and drag pattern, along with the getting element like sprue, runner and riser are mounted on a attached separately on the wooden or metal plates. These plates either made up of metal or wood, along with the alignment pins. Okay, these are the provision. Holes are provided for putting the alignment pins so that both parts can be assembled accurately. Is it right? And it is generally used for making a heavy casting which are inconvenient for handling. Is it right? These are mainly used for making very heavy casting, very big size casting which are inconvenient to handle it. Is it right? So this pattern mainly used for making a very large size casting. So this is all about scope and drag pattern, and obviously this is extension of the split piece pattern. Next, this is a matte plate pattern. So see, in the previous pattern, since both half part is made in a separate plate, so misalignment tendency is very much higher. To avoid this misalignment tendency, in this case we attach full pattern along with the getting element in a single plate. Is it right? And we just place this pattern, and above we have a drag box, sorry, coke box, and below we have a drag box. Okay, and after that, obviously, we just fill the molding sand. We just pour the molding sand in both the portion. So initially, by putting this, only one portion we fill the sand, and in the another, after inverting this, we just fill another portion, and after that we just perform ramming action so that the molding sand properly settle down and acquire adequate strength and hardness, which are essential for the pattern withdrawal. Is it right? So this types of pattern is called as mash plate pattern, and obviously this is a we can say advanced version of the cope and drag pattern. Is it right? You can see in the cope and drag pattern, the half of the portion of the pattern and the getting element is attached with the two separate plates, but here the whole getting element and the pattern is attached with the single plate. So therefore the misalignment tendency is completely avoided. And obviously this types of pattern is mainly used for making a small size casting, but of course when very high dimensional accuracy is required, then this types of pattern is very helpful. Is it right? So remember, this types of casting is mainly used for making small size casting with higher dimensional accuracy. Correct? Next, a gated pattern. So gated pattern, if I talk about, so you can see here the multiple patterns. This is pattern 1, this is pattern 2, pattern 3, pattern 4, 5, 6, 7, 8. So you can see here multiple patterns are attached with the common runner. This is a runner attached with a common runner with the help of these separate ingates. These are the separate ingates. Is it right? Separate ingates. And this is a screw through which you can pour the molten metal. Is it right? So if the getting element is an integrated part of the pattern and multiple patterns are attached with a common runner and with the individual ingates, then this types of pattern is called as gated pattern. Is it right? And this pattern, with the help of this pattern, we can make multiple objects in a single run. So basically it is suitable for making small size object with mass production. Is that right? This is very much suitable for this. Next, loose piece pattern. Loose piece pattern, I already told you. You can see here, basically, here I need to produce a casting with a shape of like this. Is it right? This shape casting actually I need to produce. And in this, you can see here, we have projection. So this is actually our product which I need to produce with the help of this sand casting process. Then obviously if you put this pattern, like this. Okay, this is your pattern, and suppose this is a mold box. I think it is not visible here, so I'm just uh, moving this. Okay, now you can see here. I think it is visible to you, and the mold box. This is a surface plate. Okay, and after placing this pattern, here I'm just filling the molding sand. Okay, This is a molding sand. And now after pouring this molding sand, what I need to do, we just want to uh, ramp properly. Is it right? So that we can acquire the adequate strength of the molding sand. Is it right? Like this. And after proper ramming, what I need to do, after proper ramming, I just want to invert this entire system like this. And of course, the surface plate is now remain at the situated at the bottom of this system like this. Okay, initially it is looking like this, and now it is situated like this. And once again, you can see after making this, after pouring and ramming, now I need to withdraw this pattern. So you can see here, since in this location we have a molding sand, so this raised portion restrict the withdrawal of the pattern. Is it right? Then it is very difficult to withdraw. So in that case, what I need to do, I just make this pattern separately. This projected portion make separately. Is it right? This projection is made separately and rest of the pattern is made separately, and we assembled both the patterns with the help of some glue. Okay, and after that you just put this pattern and fill the molding sand and do the ramming process. And while withdrawal, what I need to do, when we just take this pattern, then the bond between this small portion and the bigger portion of the pattern may break, and after that you can see this this pattern can easily withdraw separately like this, yes or no, and this raised portion or loose piece is still positioned at the mold cavity. Is it right? And once this bigger portion is removed, and now with the help of this ejector pins or with the help of some pattern removal pins, we just remove this pattern, then we will get the 3D mold cavity. And now this pattern is, sorry, mold cavity is ready for the pouring. So remember, loose piece pattern is always used when we have a projections on the casting, and due to this projection it is unable to withdraw entire casting, sorry, entire pattern in a single stroke. So in that case we make multiple pieces of the pattern, and we assembled all the pattern, and we stick all the small pieces of the pattern with the help of some glue. Is it right? And while withdrawal, obviously due to the ramming action or ramming force and by the shaking, all the pieces may separate to each other, and individually all the patterns can be removed. Is it right? So this is called loose piece pattern. So sometimes you can see casting is having projections. Remember this term, projections. Then withdrawal of the pattern from the molding sand is not possible, then such types of pattern is used. So this is called as loose piece pattern. So I hope you understand what is loose piece pattern. Next, sweep pattern. So now sweep pattern, let's suppose this is our casting which I need to produce. Okay, so obviously for a making mold cavity, we need to make this size casting, sorry, this size pattern, which is a bigger in size and huge amount of material it consumes, and obviously its weight also increases. Therefore handling of the pattern itself is a difficult task. So instead of using this whole pattern, we just use, here I'm just using a segment of the pattern. Is it right? Like this. Okay, and obviously along with this I also provide a extra portions, correct? So this is our actually pattern. You can say like this, and its thickness is very less. its thickness is very less. You can see here. Correct? So if you separate this, if you take out from the pattern, then we will say this is a pattern. Okay. So you can see it, since its thickness is very less as compared to its other dimension, therefore can I consider this is a 2D pattern? This is a 2D pattern, is it right? And now placing this 2D pattern, let's suppose if I place this pattern like this, okay, and around this we have a molding sand everywhere. Okay, and this is a pattern, and around this we have a molding sand, like everywhere moldings, we have a molding sand. Okay, and now if I revolve this pattern about this vertical axis, then obviously here we also get a cavity like the pattern shape. Yes or no? Like this. So we get this is the mold cavity, three-dimensional mold cavity. Is it right? This is the three-dimensional mold cavity. And how we will get this three-dimensional mold cavity? By revolving this pattern about its vertical axis. Is that right? So this process, this is the application of sweep pattern. With the help of this, 2D pattern, we make a three-dimensional mold cavity, three-dimensional mold cavity. Is it right? And obviously, this pattern is suitable for making a symmetrical pattern, sorry, symmetrical casting, and obviously very big size of pattern, a very big size of casting can be produced. Okay, but in this case of in this case in which we use shape pattern, we always choose loam sand over green sand. Okay, and why loam sand? Because loam sand consists of 50% 50% clay and 50% silica sand. Okay, this is approximate data, this is not, sorry, this is ideal data, not actual data. A sand which is having 50% clay and 50% sand is called as loam sand, and obviously in actual practice we use 50% sand and around 35% clay, and rest we use water. Correct. And when you prepare this sand properly, then you will get adequate strength over green sand strength. Green sand is this green strength of the loam sand is much higher than the green strength. Okay, that's why this sand is suitable for this, because when you revolve this pattern, then the sand cutting takes place. Yes or no? So we always choose a cake type of molding sand, so that it can be easily cut with the help of pattern. Is it right? Otherwise, if you have a slightly less strength sand, and when you cut with the help of pattern, then the entire sand can collapse. Is it right? To prevent this, we use this special purpose sand. Is it right? So this is a special type of pattern which is used for making symmetrical object. With the help of 2D pattern, we make 3D pattern. Is it right? And generally, it can be performed in a pit molding. Pit molding means we just dig a very big size hole in the floor surface, correct? And the entire mold cavity is prepared in the inside the pit. Okay, so this is called as a shape pattern. Next, segmented pattern. This is a similar kind of pattern as we study in the skeleton pattern, but the difference is in this we just cut a segment like this. This is a segment. Okay, this is a segment which is just exactly looking like this, and its size is thickness, width, and other size is comparable. Therefore, we consider this is a 3D pattern. And now we just put this. If I draw it's a top view, then you can see here we just put this we can say segmented pattern like this. This is a segmented pattern. This is a segment of the pattern. Is it right? This is segmented pattern. And now if it revolve about around this or this axis, then it makes a hollow cavity like this. Is it right? By cutting the molding sand. Is it right? So we get this kind of this kind of mold cavity with the help of this 3D pattern. Is it right? So this is called a segmented pattern. So in this the cavity is also 3D. So the simple thing is with the help of 3D pattern you can make a 3D cavity. So this is called a segmented pattern, and again here we use loam sand. So you can see here only the shape and size of the pattern is different. Other than the process is remain same as we studied in the sweep pattern, and it is also used for making symmetrical object. And in this we use a loam sand. Is it right? As we used in the sweep pattern. Is it right? Here we also use a segmented pattern, and it is used for making flywheel, ram wheel, etc. Is it right? So these are the some products that can be made with the help of segmented pattern. Next is skeleton pattern. Of course, when the size of the pattern is very big, is that right? So in that case, instead of making whole pattern, we just make a skeleton like this. You can see these are the skeleton. Okay, correct. And in this skeleton, we just fill the molding sand. Is it right? In this, we just fill the molding sand, and by filling this molding sand, obviously we reduce the costing of the pattern material. Is it right? And now after filling this, then we have a stickles. This is called stickles, and now the shape of the stickles is similar as the shape required for the making product. Is it right? So you just when you pass this stickles over this, then this pattern acquire the shape of the stickle. Is that right? And once you get this pattern, then obviously you just put this pattern in the mold box and fill the molding sand and do the ramming process. And again, after withdrawal of this pattern, you will get the molded cavity. So this is called as skeleton pattern. So are you getting this? In this, instead of using whole bulky pattern material, we just use the skeleton of the pattern, and after that we just fill the molding sand, fill the sand, so that we just pack this whole pattern, and with the help of stickles you can get the exact shape of the pattern. Is it right? And it is suitable for making a very large casting. Is it right? Like a turbine rotor, hydraulic turbine rotor. Is it right? Which is a very big in size. Next, you can see follow board pattern. Sometimes what happened actually, you can see here, this is a pattern whose thickness is very less, and when you put this pattern in the mold box and fill the molding sand and do the ramming, then due to the ramming force, what will happen actually? Due to the ramming force, the even pattern wall may distorted. Is it right? So to prevent this distortion, we just provide a wooden support like this. You can see here. This is a wooden support which is fitted with the pattern, this thin wall pattern. And after that, you just put this pattern in the mold box and fill the molding sand and do the same process. Then you will get the exact cavity what you exactly required with the help of this pattern. Is it right? So follow board pattern is nothing but it is a pattern which is used. It is a wooden piece which is used to support the pattern. Which type of pattern? Thin wall pattern. Is it right? So exactly देखा जाए, so follow board pattern is not a pattern. It is used to support the thin wall pattern. Is it right? So this is all about all kind of patterns. Okay. Now let's see what type of material that can be used for the pattern material. So first we'll see the selection of the pattern material. So pattern materials mainly selected based on these factors, that is service requirement, that is quality, quantity and complexity of the casting, and second, that is types of molding process, whether we use a machine molding or man molding, and easily work, shaped and joined. So these are the some factors upon which we can select the pattern material. And what are the essential properties required for the pattern? Then you can see the pattern must be a strong, hard and durable, and it must be a dimensionally stable in all situations. It is easily available, and it must be a low cost, and it must be repairable and able to make good surface finish. So these are the some essential properties of the molding sand, sorry, pattern material. Is it right? The pattern material must possess these properties. Next, what type of pattern basically we have? Then you can see we use basically wooden pattern, which is easily available, easily manufactured. Is it right? But yes, a wood pattern is having one biggest demerit, that is it is having a moisture absorbing tendency, which limits the use of this pattern. And especially this wooden pattern is basically used for making a small batch size, that is up to 50 product. More than 50 product cannot be produced with the help of this. Why? Because after using this, the wooden pattern may absorb some moisture, and because of that absorption, it may swelling takes place, and hence the size of the wooden pattern may alter. That's why this can be not used. Next, metals are generally suitable for a very large size pattern, sorry, large batch size production. Why? Because its cost is more, its manufacturing process is also costly, so it is not justified with a small batch size. Therefore it is suitable for a large batch size. Is it right? And obviously in metal there is no tendency of moisture absorption, and even if we prevent the corrosion, then its dimensional accuracy and surface finish will be much better than the wooden pattern, and it is used for very large run. Okay, and cast iron, steel, brass, aluminum are the, and white cast iron are the some metals that can be used for making a pattern. Next, wax. This is a special purpose pattern material which is especially used in the investment casting. Is it right? Next, plastic. Yes, nowadays plastic patterns are also used because we have a 3D printing technology, that is additive manufacturing technology. With the help of that, we can make a very complex pattern with the help of plastics. Is it right? And that complex pattern can be used for making a further product. And of course, pattern plastics are also having very good um, uh, moisture. You can say very good strength and hardness, and durability, and the tendency of moisture absorption is close to zero. It is not absorbing any moisture, and its surface finish may produces a very good surface of the mold cavity. So these are the some category that properties which bound us to make a pattern with the help of plastic. Is it right? And the biggest advantage you learn, this is plastic pattern can be made with the help of 3D printing. Is it right? So very complex object can be easily produced. Very complex pattern can be easily made. And epoxy resin, thermosetting, thermoplastic, polymers, polystyrene foams are the preferable plastic material that can be used for making a pattern. And nowadays silicon rubber is also used for making some kind of pattern, and especially for making integrate patterns. Okay. Next, pattern color code. So you can see red or orange color. This represents a surface not to be finished and left as a cast. Is it right? Yellow strip, and when you have yellow paint on the pattern, then it represents on surface to be machined. That surface which will be in future going to be machined. Is it right? Black color is painted for unmachined opening. Is it right? It is mainly painted on the core paint, and especially where the machining is not required. And yellow strips on the black color is represented by a core prints for a machined surface, and green color generally used for the loose pieces. Okay, so these are the some color coding through which you can identify which pattern or which surface used for which kind of purpose. Okay, now pattern selection criteria I already told you. Again, you can see casting process. It depends upon types of casting process, pattern material, production quantity, required accuracy and surface finish, size and complexity of the casting, pattern life, cost and economy, ease of handling and repair, allowances needed, and environmental resistance. So these are the some pattern criteria. These are the some selection criteria upon which we can select the pattern. Is it right? Now let's see the some MCQ types question. So before going to these questions, first I'm going to conclude this entire discussion. So in this lecture, we see how to define pattern, what type of pattern, and what are the special application of those patterns, and what are the pattern material, their selection criteria, correct, and the pattern color codes. These are things we understand. So if you watch this lecture, then you can easily aware with these things. Okay. And now let's see some MCQ type question. A match split pattern is mostly used in. So match split pattern is mainly used in machine molding over a die casting, manual molding, or investment casting. Okay, it is mainly used in machine molding. Machine material, which material is commonly used for low volume production of pattern? Low volume production basically use wooden pattern. Which of the following is suitable pattern material for large scale production? Mainly metals are used for large scale production. Okay, and the sweep pattern is generally used for what? Sweep pattern is generally used for making a very large symmetrical casting. Okay, and loose piece pattern is used when, obviously loose piece patterns are used when we have the casting is having projections. The casting is very large, so this is wrong. The pattern is made of metal, wrong. Casting is undercuts. Yes, if casting has undercuts or projections, then we use loose piece pattern. Okay, so this is all about pattern and their types and their pattern material and their application. So thank you for watching, and good day to all of you guys.